Welcome back, dear students. This should be the last and third video of demo essay. The first one we have discussed and proved the demo essay. The second one we have discussed about the nth roots of a complex number, particularly nth roots of unity, and again cube roots of unity. And in this topic, I will explain how to solve some important problems. Before that, let's recollect what we have learned in the previous classes. The first one is, every complex number z can be expressed in the mod and picture form. R into cos theta plus I sin theta, where R is the modulus of the complex number z, which is square root of real part square plus imaginary part square, that is a square plus b square, and theta is the amplitude of the complex number, that is tan inverse b by a. So every complex number can be expressed in mod and picture form. Okay, now if z is a complex number, if z is a complex number in its mod and picture form, what is z to the power of n? We know that z to the power of n is z into z into z into z n times. So it has to be the product of a sequence of n z's. We know that multiplying complex numbers and then again multiplying the product with another complex number, etc., 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 but it takes a lot of time. So this demo theorem allows us to find the powers of complex numbers in a simple manner. Whenever it is in the mod and picture form, this z, which is r into cos theta plus I sin theta, can be raised to a power of z to a power of n like this. If n is a integer, for any n belongs to n, that means this n is a integer. Maybe it is a positive integer or a negative integer, or it may be zero sometimes. Okay, so z to the power of n is r into cos theta plus I sin theta whole to the power of n. Since the modulus of the complex number z, which is r, is always a real number. We know that the modulus of any complex number is always a real number. So r is a real number. We can easily evaluate r to the power of n. So it is r to the power of n into cos theta plus I sin theta to the power of n. This is r to the power of n into. Here comes the de Moivre's theorem. And this de Moivre's theorem states that cos theta plus I sin theta to the power of n is cos n theta plus I sin n theta, as long as this n is an integer. Particularly for a unimodular complex number. What do you mean by a unimodular complex number? What do you mean by a unimodular complex number? The concept is simple. Whenever the modulus of a complex number, that is r, is equal to 1, we say that that is a unimodular complex number. So this cos theta plus I sin theta, this is a unimodular complex number whenever this r is 1. So any unimodular complex number can always be written as cos theta plus I sin theta for a particular value of theta, for any particular value of theta. And those unimodular complex numbers, they correspond to points in the organ plane which lie on a unit circle. The radius of this complex number, the radius of the circle should be equal to 1. This is the real axis. This is the imaginary axis. This is the complex number 0 plus 0i. And this is Z, where mod Z is this R, should be equal to 1. So, all points on this circle, which are at a distance of exactly 1 unit from this complex number 0 plus 0i, they are unimodular complex numbers. They are unimodular complex numbers. Okay. So this demo is straight away deals with unimodular complex numbers. And of course this, along with this demo is we have some important results. One of them is cos theta plus I sin theta to the power of minus 1. What is that? We know that as long as this n is an integer, we can apply demo as maybe a positive integer or maybe a negative integer or 0 in particular case. Still, if n is an integer, minus n is again an integer. So you can apply demo theorem for minus n as well. So this becomes cos of theta plus I sin theta whole to the power of minus n. That can be written as cos of minus n theta plus I sin minus n theta. That is exactly equal to cos of minus n theta plus I sin minus n theta. That can be written as cos n theta minus I sin n theta. Why? Why? Because the cosine function is an even function and the sine function is an odd function. So sine of minus theta automatically becomes minus sin theta. Cos of minus theta becomes cos theta. Okay. So cos theta plus I sin theta to the power of minus n can be written as cos n theta minus I sin n theta. This can also be written as, or you can say like this, or cos theta minus I sin theta whole to the power of n. What happens to this term? Cos theta plus I sin theta whole to the power of n. We can absorb this negative sign into this sine function. So automatically it becomes cos minus theta because it is an even function. Cos minus theta plus I sin minus theta whole to the power of n. So now this negative sign will be for this theta. And there is no restriction on this theta to apply demo itself. So cos theta plus cos minus theta plus I sin minus theta whole to the power of n. You can apply demo itself and you can write it as cos of minus n theta plus I sin minus n theta. So again this becomes cos of n theta minus I sin of n theta. And cos theta minus I sin theta whole to the power of minus n. What happens to this one? Data phase. You have an integration for this here or you have an integration for this theta, so that when you are multiplying n into theta, that is minus n into minus theta automatically becomes n theta. So this becomes cos n theta plus I sin n theta. So these are some of the results we have to remember. Right. After this, we have shifted our attention to nth roots of a complex number. Suppose Z is a complex number r into cos theta plus I sin theta for a particular value of r and a particular amplitude theta. Now, what is the nth root of this complex number? Naturally, there will be n different roots for this complex number Z. There will be n different nth roots for the complex number Z. So what are those nth roots? Those nth roots, they are r to the power of 1 by n into cos 2k pi plus theta divided by n plus I sin 2k pi plus theta divided by n, where k is equal to, this is the quantity we have introduced with this one. N is what you are going to find, nth roots. You are finding fifth roots means n is equal to 5. If you are finding 10th roots, n is equal to 10. If you are finding 25th roots, n is equal to 25, etc. And this k, that is what we have introduced in this. So we have to specify what this k is. K takes integers starting from 0. So it is 0, 1, 2, 3, etc. up to n minus 1. There are n different values for this K. For each of the starting from 0 goes up to n minus 1. So for each and every value of this K, you are going to get one complex number, which is the nth root of Z. So for n such values of K, you are going to get n such nth roots of this complex number Z. So particularly, if you are finding nth roots of unity means 1. So 1 to the power of 1 by n. So the roots of this, nth roots of this 1, what are they? Simple logic. The magnitude of this modulus of this complex number, which is r, in this case it has to be equal to 1. So it is 1 to the power of 1 by n, which is 1, into cos of 2k pi plus 0 divided by n plus I sine 2k pi plus 0 divided by n, where k is equal to 0, 1, 2, 3, etc. up to n minus 1. So these are the nth roots of this 1. They are nth roots of unity. In short form, we are going to write them as cis 2k pi by n. K is 0, 1, 2, 3, etc. up to n minus 1. Right. Particularly, the cube roots of 1. So the cube roots of 1 are the cube roots of 1 means that n is equal to 3. So answer will be cis 2k pi by our n now is 3, where k takes the values 0, 1, 2. 3 roots. So if you want to look at the roots individually, what are the roots? For k equal to 0, the first one is cis. K equal to 0 means 2 into 0 into pi by 3, that is cis 0. The other one is for k equal to 1, cis 2 pi by 3. For k equal to 2, the last root is cis 4 pi by 3. So these are the cube roots of unity. If you want to convert them to the form a plus ab, so what are those values? Cis 0 means cos 0 plus I sine 0. That is, cos 0 is 1 and sine 0 is 0, which is 1, which is a real root. So of the cube roots of unity, one of them will be the real root. The remaining two are complex roots. This is a real root. The other one is cos 2 pi by 3 plus I sine 2 pi by 3. You know that cos 2 pi by 3 is minus 1. Sine 2 pi by 3 is root 3 by 2. So it is minus 1 plus root 3i by 2. The last one is cos 4 pi by 3 plus I sine 4 pi by 3. And you know that cos 4 pi by 3 is again minus 1 by 2, whereas sine 4 pi by 3 is also, sine 4 pi by 3 is minus root 3 by 2. So that it becomes minus 1 minus root 3i by 2. Okay. And then we call this one as omega, and observe that this is omega square. If this is omega square. Or alternatively, if this is omega square. So the points I have mentioned in the last class are, first one is omega cube is equal to 1. In general, omega to the power of any multiple of 3, omega to the power of 3k should be equal to 1 for any integer, k. For any integer k, omega to the power of 3k should be equal to 1. That is simple. Omega cube whole to the power of k. And we know that omega cube is 1. So 1 to the power of k is 1. That's the first point we have to remember. The next one is sum of these cube roots of unity, that is 1 plus omega square should be equal to 0. The third one is omega square is equal to omega bar. One is the conjugate of the other. So this is conjugate of this one. Or this is the conjugate of this one. So omega square is equal to omega bar, and omega bar square is equal to, or omega square bar is equal to omega. The next one is omega square is equal to 1 by omega, or omega is equal to 1 by omega square. One is the reciprocal of the other. This is the reciprocal of this one, and this is the reciprocal of this one. So that the product of these two is equal to 1. You know that the product of these two should be equal to 1. The product of these two should be equal to 1. Look at this. Cross multiply the terms. Omega square into omega, that is omega cube, should be equal to 1 by virtue of this result. So omega cube is equal to omega 1. Omega cube is equal to 1. Straight away gives omega square equal to 1 by omega, or omega equal to 1 by omega square. So these are the points you have to remember to solve a few problems. To solve a few problems on these omega. So let's see a few problems on this. If omega is a complex cube root of 1. If omega is a complex cube root of 1, that means it is not a real number 1. It is minus 1 plus root 3a by 2, or minus 1 minus root 3a by 2. Okay. If omega is a complex root of 1, find omega plus 1 by omega square plus omega square plus 1 by omega square plus omega cube plus 1 by omega cube square plus omega to the power of 4 plus 1 by omega to the power of square plus omega to the power of 5 plus 1 by omega to the power of 5 square plus omega to the power of 6 plus 1 by omega to the power of 6 square. Find the value of this expression. Find the value of this entire expression. Okay. How to find this one? So that's not a problem. The given expression is, look, this is omega plus 1 by omega. You know that 1 by omega is omega square. So this automatically becomes omega plus omega square whole square. Omega plus omega square whole square. Plus, look at the next one, omega square plus, what is 1 by omega square? 1 by omega square is omega square plus, for the third term, omega cube plus 1 by omega cube. We know that omega cube is 1, so it is 1 plus 1 square plus, what is the next term? Omega to the power of 4 plus 1 by omega to the power of 4. We know that omega to the power of 4 is omega cube into omega, which is omega. So omega to the power of 4 is omega plus 1 by omega to the power of 4 is 1 by omega, which in turn becomes omega square. And it's square. Plus the next term, omega to the power of 5 plus 1 by omega to the power of 5. Omega to the power of 5 is omega cube into omega square, which is omega square because omega cube is 1. So this is omega square plus the other one is 1 by omega square, which in turn is omega. And it's square. Plus the last one, omega to the power of 6. We know that 6 is a multiple of 3. If it is a multiple of 3, omega to the power of 6, that should be equal to 1. So it is 1 plus 1. This is also 1. So 1 plus 1 is 1. So, applying these properties, we got this one. Now this becomes, what is omega plus omega square? Now look at this equation. 1 plus omega square is equal to 0. So omega plus omega square is equal to minus 1. So it is minus 1 square plus, this is again omega plus omega square, which is minus 1 square, plus 1 plus 1, that is 2 square, 4, plus this omega plus omega square again minus 1 square, plus omega plus omega square again minus 1 square, plus 1 plus 1, that is 2 square, which is 4. So on simplification, what happens to this one? 1 plus 1 plus 4, that is 6, plus 1 7, plus 1 8, plus 4, which is 12. So this value of this entire expression is equal to this 12. Okay, this is the way such problems can be solved using these results. Let's see one more problem. If omega is a complex cube root of 1, find the value of 1 minus omega plus omega square, 1 minus omega plus omega square whole square, plus 1 plus omega minus omega square whole square, plus omega plus omega square whole square. Find the value of this expression. I have taken the problem randomly. So how to find the value of this expression? You have the properties with you. Simplify this. Using these properties, you will get the required value. Look, this expression is 1 minus omega plus omega square whole square. 1 plus omega square from this equation. 1 plus omega square is equal to minus omega. So already you have this one more minus omega. So minus omega, and the sum of these two terms is equal to minus omega. So it is minus omega square plus this one 1 plus omega. From this 1 plus omega is equal to minus omega square, and you have one more minus omega square plus, and look at the last one, omega plus omega square. Omega plus omega square is equal to minus 1 square. Okay, this is equal to, you may have this minus 1 also here, omega plus omega square minus 1. In that case, you are going to get minus 1 whole square. That's it. Now, minus omega is minus 2 omega square. So minus 2 cube is minus 8 omega square. Minus 8 omega square. Oh, sorry, minus 2 square is, minus 2 whole square is 4. And this one is omega square. And look at the next one, minus omega square. It's minus 2 omega square whole square. So it is plus 4 omega to the power of 4. Plus 1 this one. Okay. Minus 1 square is 1. Now this is 4 into omega square plus omega to the power of 4. Mind you, omega to the power of 4 is omega cube into omega, which is omega. Plus 1. And this is 4 times omega square plus omega. Omega square plus omega is minus 1 plus 1. So on simplification, this becomes minus 4 plus 1, that is minus 3. Just answer. Okay, this is the way such and such problems can be solved, which involves this omega. Now, how to write the nth roots of a complex number? Say for example, a problem will be given a different way. Find all the values of source of complex number to the power of 1 by 4 or 1 by 7, etc. Say for example like this. Find all the values of 7, say 1 minus I whole to the power of 1 by, say 5. Find all the values of 1 minus I whole to the power of 1 by 5. That means you are asked to find the fifth roots of the complex number 1 minus I. The fifth roots of the complex number 1 minus I. So how to find the fifth roots of a complex number? First of all, you have to write it in the modern picture form. Then you can write straight away the fifth roots. So this 1 minus I should be written as r into cos theta plus I sin theta, where r is equal to, for this 1 minus I, r is equal to square root of a square plus b square. A square is 1 square which is 1, plus b square is minus 1 square which is 1, which is root 2. So it is root 2 into theta. Theta is tan inverse b by a. B is minus 1 by a is plus 1. So tan inverse minus 1 by plus 1. Tan inverse minus 1 by plus 1. So what should be the amplitude? Mind you have to exercise caution while identifying what this theta is, what this amplitude theta is. So for that, we have to keep the signs of A and B separately. Never simplify the signs. If it is minus by minus, don't write it as plus. If it is plus by minus, don't write it as minus of something. You don't simplify the signs. Keep the signs of both the numerator and denominator separately, intact. That allows us to identify the amplitude from this simple diagram. Look, this is the real axis. This is the imaginary axis. Our complex number is 1 minus I. The real part is 1 unit. So you have to move 1 unit towards the right of this complex number 0 plus 0a along this real axis. 1 unit. And imaginary part is minus 1 unit. So you have to go this way. So it is minus 1 unit. So the complex number will be somewhere here. This is the complex number 1 minus I. This is the location of this Z, 1 minus I. Now join these two. So always for the amplitude of a complex number, join the complex number with 0 plus 0i. In other words, origin in this horizontal plane. I may not call it as the origin. For our understanding, I am just calling it as origin. In fact, it is actually the complex number 0 plus 0i, absolute 0. So join these two pointers. Now, you have to measure the quantum of rotation from the real axis, the positive real axis. This is the positive real axis. You have to measure the quantum of rotation from the positive real axis to coincide with this z. If this measurement is in the anti-clockwise direction, you have to take it as positive. If it is in the clockwise direction, you have to take it as a negative. Now look, from the positive real axis, the quantum of rotation, proceeding in the clockwise direction. So it has to be negative quantity. What is this quantum of rotation? For that, now look at, forget about the signs and take this value, 1 by 1 which is 1. And tan inverse 1 is pi by 4. And you are measuring in the clockwise direction. So it has to be minus of pi by 4. That is minus pi by 4. Okay? If the complex number is minus 1 minus I. For example, the complex number is minus, call it as Z1, minus 1 minus I. What will be the amplitude for this? The amplitude for this is theta, that is tan inverse, minus 1 by minus 1. Imaginary part is minus 1 units and the real part is minus 1 units. So what is minus 1 by minus 1? Don't call it as simply plus 1 and write it as pi by 4. No, you should not do that. that corresponds to pi by 4. But where is the location of that one? The location that gives, just by plotting this point Z1 in this organ. Look, the real quantity is minus 1. So we have to proceed this way. This is minus 1. And you have to move along the negative imaginary axis because the imaginary quantity is at a minus 1. So, minus 1. So this is our Z1, which is minus 1 minus 7. Now for the amplitude, join this. How do you have to measure the quantum of rotation? And this rotation starts from positive axis. So from this, there should be the quantum of rotation. We are measuring in the anti-clockwise direction, so it has to be positive quantity. Plus, what will be the quantum of rotation? This is 180 degrees, plus this part is equal to 45, which is pi by 4. Forget about the signs, and it is tan inverse 1, which is pi by 4. So it is pi plus pi by 4. 5 pi by 4. Pi plus pi by 4, which is 5 pi by 4. So the amplitude of this complex number minus 1 minus I is 5 pi by 4. The amplitude of the complex number 1 minus I is minus pi by 4. So always exercise caution while writing the amplitude of a complex number. Okay. So once we have these two quantities, we have the mod amplitude form of 1 minus I, which is root 2 into cos minus pi by 4 plus I sine minus pi by 4. Now, the values of 1 minus I to the power of 1 by 5 are. Now we are writing the values of this 1 minus I to the power of 1 by 5. That is the fifth roots of 1 minus I. They are r to the power of 1 by n, or is root 2 to the power of 1 by our n is 5. So it is root 2 to the power of 1 by 5 into cis. Cis means cos plus I sine. What will be the amplitude? The amplitude is 2k pi plus 2k pi plus theta. What is this theta here? That is minus pi by 4. All divided by our n is 5. Where k can take the values 0, 1, 2, 3 and 4. You have 5 such values. 0, 1, 2, 3, 4. So, these are the values of 1 minus I to the power of 1 by 5. If we want to identify the values separately, all that you have to do is substitute 0 here for the first of these roots. Substitute k equal to 1 here, you will get the next root. You will get k equal to, for k equal to 2, you will get the next one. For k equal to 3, the next one. And for k equal to 4, you got the last and fifth root. You got the values. Suppose the problem is slightly changed. You are not asked to find all the values of this one. You are supposed to find the product of all the values of this 1 minus I to the power of 1 by 5. You have 5 such values here. You are asked to find the product of all these 5 values. So what is the product? Now, the product of all the values of 1 minus I to the power of 1 by 5 is what is equal to. So what are the values? 2 to the power of root 2 to the power of 1 by 5 is 2 to the power of 1 by 10. So it is 2 to the power of 1 by 10. Says, I am writing the values separately. For k equal to 0, this is minus 5 by 20. 4 into 5, 20. That's the first one. The next one is 2 to the power of 1 by 10 into says, mind you, for all those values, the modulus r, that remains to be the same. So if it is 2 to the power of 1 by 10, it is 2 to the power of 1 by 10, 2 to the power of 1 by 10, etc. Each and every root will have the same modulus. Only the amplitude changes. Okay. So what will be the amplitude of the next one? That is for k equal to 1. So for k equal to 1, this becomes 2 into 1 into pi, that is 2 pi minus pi by 4 whole divided by 5. So it is 2 into 4, that is 8. 8 pi minus pi is 7 pi. 7 pi by 4 into 5 is 20. So 7 pi by 20. What will be the next one? 2 to the power of 1 by 10 into says. How do you get the next amplitude? For k equal to 2. For k equal to 2 into 2 is 4. So 4 pi minus pi by 4 whole divided by 5. This is 16 minus 1. 15 pi by 20. And I have already mentioned that for the nth roots of a complex number, the amplitudes will be in the arithmetic progression. They will be in the arithmetic progression. Minus pi by 20 plus 7 pi by 20. What is the difference between these two? 8 pi by 20. If you add 8 pi by 20 for this, you will get the next amplitude. For the next amplitude, you have to add again 8 pi by 20, etc. So, the next one is 2 to the power of, you are writing the product. So, the first one into the second one into the third one into the fourth one, that is 2 to the power of 1 by 10 into says. This corresponds to k equal to 3. So for k equal to 3, this becomes 2 into 3, that is 6 pi minus pi by 4 by 5. 6 into 5 is 6 into 4 is 24, minus 1 is 23. 23 pi by 20. And finally, the last one is 2 to the power of 1 by 10 into says 7 pi by 20 plus 8 pi by 20, which is 15 pi by 20 plus 8 pi by 20, that is 23 pi by 20 plus 8 pi by 20. 33 plus 8, that is 23 plus 8, that is 31 pi by 20. Or alternatively, that corresponds to k is equal to 4. So 2 into 4, that is 8 pi minus pi by 4 by 5. 4 into 8, 32 minus 1, 31 pi by 20. So this is the product of all the values. And you can simplify this further. This is 2 power 1 by 10 into 2 power 1 by 10 into 2 power 1 by 10. So we have 5 such terms. So it is 2 power 1 by 10 whole to the power of 5 into says. Let's recollect the product of complex numbers in the mod amplitude form. Cis alpha into cis beta into cis gamma into cis delta is cis alpha plus beta plus gamma plus delta, etc. Likewise, this is cis, the first amplitude plus second amplitude plus third amplitude plus fourth amplitude, etc. So it is minus pi by 20 plus 7 pi by 20 plus 15 pi by 20 plus 23 pi by 20 plus 31 pi by 20. This is 2 to the power of 1 by 2. You are going to get R here. What is our R? Root 2. So you are getting R here. That is root 2. Into says, look at the sum of these values. This 20 is common for this. Now look at the sum of the numerators. This is minus pi plus 7 pi, that is 6 pi. 6 plus 15, 21 pi. 21 plus 23, that is 44. 44 plus 31. 74 plus 1, 75 pi by 20. 54, 69, 76 minus 1. 75 pi by 20. That is the product of all those values. We can still simplify this one. This is root 2 into says. Look, 75 pi by 20. That can be written as That can be written as 15 pi by 4. You can cancel this part. 5 into 15 and 4 into 5. You cancel this part. 15 pi by 4. This can be written as root 2 into 6. 15 pi by 4. How can you write this one as 15 pi by 4? That can be written as 16 pi minus 5 by 4. That is root 2 into 6. 16 pi by 4 is 4 pi minus 5 by 4. This is root 2 into 6 minus 5 by 4. Both cosine function and sine function, they are periodic functions of period 2 pi. So you can add and subtract 2 pi any number of times. For the fixed angle, that is minus 5 by 4, the value will not change. So this is the value. And you know what is cos minus 5 by 4 or sine minus 5 by 4? You can substitute and simplify. You will get the required. Okay, so that is a product of all such values of this 1 minus I to the power of 1 by 1. So this problem corresponds to finding the fifth roots of the complex number. And then we have extended the problem a bit further. Okay, now comes one important property. If cos alpha plus cos beta plus cos gamma is equal to 0, which is sin alpha plus sin beta plus sin gamma, then show that number 1, cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 times cos alpha plus beta plus gamma. And the second bit is sin 3 alpha plus sin 3 beta plus sin 3 gamma. It should be equal to 3 times sin alpha plus beta plus gamma. So this result. How can you prove this result? So if you remember, this cos alpha, cos beta, cos gamma, they will be the real parts of the complex number when it is in the mod amplitude form. And sin alpha, sin beta, sin gamma, they will be the imaginary parts of the complex numbers when they are in the mod amplitude form. So, in other words, you can club these two to write a complex number in the form cos alpha plus I sin alpha. Let's call that complex number as A. So, the solution goes like this. Let A is equal to cos alpha plus I sin alpha. B is equal to cos beta plus I sin beta. And C is equal to cos gamma plus I sin gamma. Let's consider three complex numbers A, B, C. This way. Now what is A plus B plus C? Then A plus B plus C is equal to sum of the three complex numbers. If you add multiple complex numbers, all that we have to do is sum of the real parts, which constitutes the real part of the summation, plus the imaginary part of the summation is sum of the imaginary parts. So, what is the real part of A plus B plus C? Sum of all the real parts, cos alpha plus cos beta plus cos gamma, which is 0 by virtue of this one. So, it is 0 plus I into what is the imaginary part of this A plus B plus C? Sin alpha plus sin beta plus sin gamma, which is again 0. So, A plus B plus C is equal to 0. And we know that whenever A plus B plus C equal to 0, AQ plus BQ plus CQ is equal to 3 times ABC. Why we are considering AQ plus BQ plus CQ? Because you have to find cos 3 alpha plus cos 3 beta plus cos 3 gamma. Similarly, sin 3 alpha plus sin 3 beta plus sin 3 gamma. In other words, you need to get cos 3 alpha plus I sin 3 alpha. That is cos alpha plus I sin alpha whole cube. That's why we are using this research. Okay, so this is a cube plus b cube plus c cube is 3abc. What is a cube? Our a is cos alpha plus I sin alpha. So a cube is cos alpha plus I sin alpha whole cube. Whole cube plus b cube is cos beta plus I sin beta whole cube plus c cube is cos gamma plus I sin gamma whole cube is equal to 3 times ABC. Our A is cos alpha plus I sin alpha. B is cos beta plus I sin beta. And C is cos gamma plus I sin gamma. This is what we got because of this one or because of this one. Now, let's apply de Moivre for this. Cos alpha plus I sin alpha whole cube is cos 3 alpha plus I sin 3 alpha. Yes. And this one, cos beta plus I sin beta whole cube is cos 3 beta plus I sin 3 beta plus, and this one is cos 3 gamma plus I sin 3 gamma is equal to 3 times. What is the product of these complex numbers? Now we can see that each of these complex numbers are in the mod amplitude form. So whenever they are in the mod amplitude form, straight away you can write the product by simply adding their amplitudes. So this is again cos of. What will be the amplitude of the product of these three? That is the sum of the individual amplitudes. So alpha plus beta plus gamma plus I sin alpha plus beta plus gamma. So this is what we got. Now, look at this. It is the sum of three complex numbers, which has to be a complex number. And on the right side, you have a complex number multiplied with a constant, which is again a complex number. So you have a complex number is equal to another complex number. So when two complex numbers are equal, naturally their real parts are equal and their imaginary parts are equal. So what is the real part of the left-hand side expression? So the real part of the left-hand side expression is sum of all the real parts, which is cos 3 alpha plus cos 3 beta plus cos 3 gamma should be equal to the real part on the right side, which is cos of alpha plus beta plus gamma multiplied with this two. So it is 3 times cos alpha plus beta plus gamma. This is equating the real parts. If we equate the imaginary parts, this is the imaginary part, this is the imaginary part, and this is the imaginary part. So sum of the imaginary parts is sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to, I am not writing this side. This side indicates that this is a quantum of imaginary part. This is for indication. This is the imaginary part that is signified by writing this side. So actually the quantum of imaginary part is sin 3 alpha. So sin 3 alpha plus sin 3 beta plus sin 3 gamma should be equal to the imaginary part on the right side, that is 3 into sin of alpha plus beta plus gamma. We got the results. Okay. So this is the way such problems can be solved. Now, suppose you are asked to find let me take one problem. You are asked to prove that there's a third part. which is this one. Cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha. Prove that this is equal to 0. Prove that this is equal to 0. How can you prove this result? Ditto case. For the solution, we will start with A equal to cos alpha plus I sin alpha, B equal to cos beta plus I sin beta, and C equal to cos gamma plus I sin gamma. And we know that A plus B plus C is equal to sum of the three complex numbers, that is cos alpha plus cos beta plus cos gamma, plus I into sin alpha plus sin beta plus sin gamma. By virtue of these two results, we are 0 and 0. So it is 0. A plus B plus C equal to 0. This implies A square plus B square plus C square plus 2 times AB plus BC plus CA should be equal to 0. A plus B plus C 0 means A plus B plus C whole square is equal to 0. Or you can write it as A square plus B square plus C square is equal to minus 2 times AB plus BC plus CA. Minus 2 times AB plus BC plus CA. And look at this structure. If you take out this ABC as a common factor, that becomes 1 by A plus 1 by B plus 1 by C. Or simply, AB is, when you multiply these two complex numbers, cos alpha plus I sin alpha into cos beta plus I sin beta, that is simply cos alpha plus beta plus I sin alpha plus beta. So this quantity gives this cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha, etc. So this is what we need. We are not interested in this term. So now I am not taking this A plus B plus C whole square. The logical way of thinking. So I am not considering A plus B plus C whole square. Then I am going to get this quantity 1 by A plus 1 by B plus 1 by C, which is AB plus BC plus CA by ABC. Okay. So if A is cos alpha plus I sin alpha, then 1 by A is cos alpha minus I sin alpha. 1 by B is cos beta minus I sin beta. And 1 by C is cos gamma minus I sin gamma. So these are 1 by A, 1 by B and 1 by C. Now 1 by A plus 1 by B plus 1 by C is equal to, again the sum of the three complex numbers. Again the sum of the real parts, cos alpha plus cos beta plus cos gamma, that is 0, plus or minus I into, so it is minus I into sum of the imaginary parts, sin alpha plus sin beta plus sin gamma, which is again 0. So 1 by A plus 1 by B plus 1 by C is also 0. A plus B plus C is 0. 1 by A plus 1 by B plus 1 by C is also 0. If 1 by A plus 1 by B plus 1 by C is 0, this becomes AB plus BC plus CA by ABC is again 0. Just I am taking here. So this implies AB plus BC plus CA is equal to 0. Now what is AB, what is BC and what is CA? That you need to write. So this implies AB, that is cos alpha plus I sin alpha into cos beta plus I sin beta plus, this is our AB. What is BC? Cos beta plus I sin beta into cos gamma plus I sin gamma plus third one is CA, that is cos gamma plus sin gamma into A, which is cos alpha plus sin alpha should be equal to 0. Now each of the terms is the product of two complex numbers. So this is cis alpha into cis beta. We know that cis alpha into cis beta is cis alpha plus beta. So the product of these two is cos alpha plus beta plus sin alpha plus beta. Yes? What is the product of these two terms? Cos beta plus gamma plus sin beta plus gamma. Plus, what is the product of these two terms? Cis gamma into cis alpha is cis gamma plus alpha. That is cos gamma plus alpha plus sin gamma plus alpha. It should be equal to 0. This is a complex number, this is a complex number, and this is a complex number, sum of three complex numbers, which is again a complex number. It should be equal to 0, which is 0 plus 0i, that is again a complex number. Still, two complex numbers are equal. That means the real parts are equal and the imaginary parts are also equal. So equal in the real parts, cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha should be equal. These are the real parts. Sum of these real parts is equal to this real part 0. We got this result. If we equal the imaginary parts, sin alpha plus beta plus sin beta plus gamma plus sin gamma plus alpha is again equal to the imaginary part on the right side is equal. You may be asked to prove this one or both. We will get this result. So this is an important problem for 7 marks. You can see it frequently in the public exams. This is the way the problem can be solved. So, I repeat again, we will start with three complex numbers A, B, C. Taking them as cos alpha plus sin alpha, cos beta plus sin beta, and cos gamma plus sin gamma. Then, for these, take straight away A plus B plus C, that becomes 0. And automatically A cube plus B cube plus C cube is equal to 3ABC. You will get this result by equating the real and imaginary terms. For this one, you need to get AB plus BC plus CA. For that, we have to consider 1 by A, 1 by B, 1 by C, which is cos alpha minus sin alpha, cos beta minus sin beta, and cos gamma minus sin gamma. And the summation, that is 1 by A plus 1 by B plus 1 by C is equal to 0. That means AB plus BC plus CA equal to 0. By straight away multiplying the complex numbers and equating the real and imaginary parts, we got this result. So this is how the problems can be solved from the question. And finally, sometimes you may be asked to solve polynomial equations of the form x power n minus 1 equal to 0. So for example, solve the equation x power 5 minus 1 equal to 0. How to solve this equation? That's not a big thing. X power 5 minus 1 equal to 0. That means x power 5 equal to 1. That means x equal to 1 to the power of 1 by 5. That means x is equal to 1 plus 0i to the power of 1 by 5. That means cos 0 plus I sin 0 whole to the power of 1 by 5. Isn't it? This is 1. This is 1 plus 0i. In the modern picture form, this is cos 0 plus I sin 0 whole to the power of 1 by 5. In other words, you are writing the fifth roots of the complex number cos 0 plus I sin 0. You know all the fifth roots of the complex number cos 0 plus I sin 0. The solutions are. What are the solutions? R to the power of 1 by 5, where our R is 1. So it is 1 to the power of 1 by 5. You need to write it again. So, says, cos plus I sin, says 2k5 plus our theta is 0 divided by, you are finding the fifth rows. So it is 5, where k can take the values. Fifth rows, so 0, 1, 2, 3, and 4. We got the solutions of this equation. Suppose the equation is x to the power of 9 minus 1 equal to 0. What is the difference? X power 9 minus 1 equal to 0 means x is equal to or x power 9 equal to 1. That means x equal to 1 to the power of 1 by 9. That means instead of the fifth rows, you are asked to find the ninth rows. If this is the formula for the fifth rows, what is the formula for the ninth rows? Data phase r to the power of, that is 1 to the power of 1 by 9, which is 1 into cos plus I sin 6, 2k pi plus the same 0 because this is the same 1 here. So cos 2k pi plus 0 divided by, now in this case, we are going to write 9 because our n is equal to 9. Where k can take the values 0, 1, 2, 3, 4, etc. up to 8. You have to take 9 such values. This is a way to solve equations of this type. Suppose the equation is not x power 9 minus 1 equal to 0. If it is x power 9 plus 1 equal to 0, what happens? It doesn't change much because x power 9 plus 1 equal to 0 implies x power 9 is equal to minus 1. That means x is equal to minus 1 to the power of 1 by 9. What is this minus 1? This is cos pi plus I sin pi whole to the power of 1 by 9. This is a mod amplitude form for this minus 1. What is our modulus? Square root of minus 1 square plus 0 square, which is 1. There's 1 here. What is amplitude? Tan inverse 0 by minus 1. Tan inverse 0 by minus 1. How to locate the 0 by minus 1? Tan inverse 0 by minus 1. How to identify that angle? That is pretty much simple. Just look at the organ. This is the real axis. This is the imaginary axis. This point is minus 1 plus 0i. So the real part is minus 1 units. 0i. For the imaginary part, you need to leave this real axis. This is the point 0 here. Now what is the quantum of rotation? The quantum of rotation is always from the positive real axis. So from here to here. What is this quantum of rotation? 5. This one. So what are the solutions of this equation? Now the solutions of this equation are 1 to the power of 1 by 9, which is 1, into cos plus I sin, that is 2k pi plus, now our theta is 5. So 2k pi plus 5 divided by 9, our n is 9. Where k takes a value 0, 1, 2, 3, 4, etc. up to 8. This is a way to solve the equations of the type either x power n minus 1 equal to 0 or equations of the type x power n plus 1 equal to 0. You can solve those equations here. Okay. So, with this, we conclude this topic. So, with this explanation and the concepts with you, you can solve as many problems as possible. If at all you have a few doubts, you can reach us and you can reach me. You have my number that will be on the channel for you. So you can reach me through WhatsApp. No problem, I will explain you. You get the concepts or clarify your doubts. Okay? Thank you.
Good morning to all. Good morning to all. This is A. Manikera, lecturer in economics. Good morning to all. This is A. Manikera, lecturer in economics, working in Andhra Pradesh Residential Junior College, Nagarjuna Sagar. I welcome you all into my online classes. So, in earlier, we have been discussed in our second year economics, second chapter, that is population and human resource development. In this chapter, some of the concepts that already we have been discussed, but I have left some important concepts in this chapter. So that chapters now I am going to explain, because these concepts are very important for IBE. Today I would like to explain 4 important concepts. That is, first one is occupational distribution of population. Occupational distribution of population in India. Occupational distribution of population in India. This question very often they are asking for IBE exams. Occupational distribution of population in India. Generally, in this topic, we could see different people in a village. They are engaged in different occupations. Say, for example, what is your father's profession? You might say that my father's profession is agriculture. If I ask somebody, what is your father's profession? My father's profession is a software or hardware. What is your father's profession? Occupation is, my father is working as a bus driver or post master or lecturer or some clerical jobs. So this is an occupation. If we see in a village, agriculture is a main occupation for majority of the people. In a urban areas, industrial work is the main occupation for urban people, because in urban areas, majority of small scale industries or some cottage industries or some factories are established, so that majority of the people they have to engage in industrial occupations. Similarly, if we see the MNCs, multinational corporations, or some pharmaceutical industries, or software industries, or hardware industries, there we could see the more people they worked as a software, hardware, or engineering work, or some mechanical work. These type of works are there in metropolitan cities and developed countries. But here our topic is occupational distribution of population in India. Occupational structure of a country refers to the distribution or division of population. Occupational structure of a country refers to distribution or division of population. Or we can say in another word, occupational structure indicated the distribution as well as absorption of population into different works. Occupational structure of it indicated the distribution as well as absorption of people engaged in different occupations or works. In developing countries, majority of the people depends on or engaged on agricultural sector and other primary activities. Even some developed countries like Japan, England and Norway, fishing continues to be an important occupation. Fishing, catching fishes. In these countries, Japan, England and Norway, fishing continues to be an important occupation, providing employment to a substantial number of population. So that is the meaning of occupational distribution of population. People engaged in different categories. So there are some definitions. What are the definitions given by different economists with regard to occupational distribution of population? First, we could see the Simon Kuznets. Simon Kuznets. He has defined when the development of a country takes place, the percentage of people engaged in agriculture sector or primary sector should shift to industries and service sector. The percentage of depends on agriculture sector should shift to industrial and service sector. That is the definitions given by Simon Kuznets. Whereas another person also which has defined that Hans Singer also he has defined that economic development can be achieved by transforming of 85% of agriculture dependency country to 15% of agriculture dependence country. 85% ఉన్నటువంటి జనాభా 15%కి అగ్రికల్చర్ సెక్టార్లో దగ్గర transform people engaged on agriculture sector to other sectors. The percentage should be reduced from 85 to 15%. 85% of people depends on agriculture sector should reduce 15% of people depends on agriculture sector. So it shows that there is a occupational shift will be there. So here there is always close relationship between so then coming to occupations, different occupations, if we see primary occupations, secondary occupations and tertiary occupations. Primary occupations, secondary occupations. Occupations means వృత్తులు and tertiary occupations. Tertiary occupation. First one is primary, secondary and tertiary. Primary occupations also called as agricultural sector. So in the agriculture sector, which includes generally the fishing, forestry, animal husbandry, poultry farming, horticulture, prawn culture, tissue culture, sericulture and aquaculture. There are many things are included in agricultural sector. Agricultural sector. These products essentially needs for human existence. They are carried with the help of nature. These occupations must be carried with the help of nature. But still, majority of the people depends on agricultural sector. Agricultural sector. Then coming to secondary occupations. Secondary occupations also called as industrial sector. Industrial sector. In industrial sector, what are those generally in industrial sector? Mining, quarry, manufacturing, electricity, gas and water supply construction. These are all comes under industrial sector, which includes mining, quarrying, manufacturing, electricity, gas, water supply and manufacture. These are all comes under industrial sector. Then coming to tertiary occupations. Tertiary occupation is also called as service sector. Service sector. Service sector. So under which generally it includes trade, commerce, transportation, storage, communication, banking, insurance, real estate, personal administration, social services, more education and health. These are all services. Generally, trade, commerce, storage, communication, banking, insurance, real estate, community services, personal services, education and health. These are all comes under tertiary sector. Tertiary sector. So therefore, here always there is a always close relationship between the development of an economy and the occupational distribution of people. There is always close relationship between the development of a country and changes in occupational distribution of population. If more and more people, if they shift from agriculture sector to other sector, it leads to economic development. Then we have to see what is the absorption of each sector. Agriculture sector, what is the dependency of the population. Whereas industrial sector also, what is the dependency of industrial sector and service sector, what is the dependency. Year-wise, we see primary occupation, secondary occupation, tertiary occupation. Here from 1951, 1981, 2001 and 2011. Then here, primary sector during 1951, 72.1%. 72.1%. When it comes to the 1981, it is 71.8%. Whereas in the year 2001, 56.7%. Whereas recent year, that is 48.9%. 48.9% people depends on agriculture sector. So it means if we see the 1951, the dependency on agriculture sector is very high because during that time there is no development in other sectors. So when it comes to the 2011, the dependency on agriculture sector continuously decreasing. Then coming to the secondary sector. Secondary sector is 10.7%, 12.2%, 18.2%, then coming to 24.3%. In a industrial sector, the absorption of people, it is gradually increasing, not speed, it is gradually increasing. Then coming to the tertiary sector, it is 17%, 17.2%, 16.0, then 23, 25.1%, whereas 26.8% is service sector. The dependency of service sector, it is also gradually increasing. It means still agriculture sector dependency is very high. It's very high. So this is all about occupational distribution of population. In this, what we have seen, what is the occupational distribution of population? What is the definitions of occupational distribution of population? And what are the different occupations? Under primary occupations, what are included? Under secondary occupations, what are included? Under the tertiary sector, what are the things which are included? And we see finally from year-wise 1951 to 2011, what is the dependency on each sector? Each sector. It is very important for 5 marks. It's very important for 5 marks. I think this is very, you could catch this. Okay? Thank you. Then, coming to meaning and importance of human resource development. Meaning and importance of human resource development. Meaning and importance of human resource development. HRD. Meaning and importance of human resource development. Human resource development. What is HRD? HRD means human resource development. Human resource development, as we know, it plays an important role in economic development of any country. Economic development of any country. Because it refers to the process of acquiring and increasing in number of persons who are having the skills, education, capabilities, and positive work attitude with experiences for economic development of any country. Generally, it means it is the process of acquiring a number of people have skills, education, capabilities, capacities, and positive work attitude with experience. So therefore, HRD, human resource development, is always associated with man and his development. HRD, human resource development, is always associated with the investment in man and his development as a creative and productive resources. According to Charles Schulz, Schulz argued that investment in education enhance human capital and its wider sense. Investment on education enhance human capital in its wider sense. Investment in human capital means investment in human capital. Investment in human capital means expenditure on health, education, training, and social services. Education, trainings, health, and social services. In general, agriculture has recognized most of the attention. In fact, a effective use of physical capital itself is dependent on human resources. In fact, the effective use of physical capital itself is dependent on human resources. What is the importance of human resource development? Importance of human resource development. If there is a under-investment in human resource, the rate at which the additional physical capital can be utilized will be limited. If we reduce the investment of human capital, automatically the additional physical capital or output can be utilized will be limited. So technological, professional and administrative people require making effective use of material resources. Technological, professional and administrative people require making effective use of material resources. ఉన్నటువంటి అందుబాటులో ఉన్నటువంటి రిసోర్సెస్ని వినియోగించి హ్యూమన్ రిసోర్సెస్ని యాడ్ చేస్తూ ఉత్పత్తిని సాధించినట్లయితే ఆ దేశం మానవ అభివృద్ధి రంగంలో వృద్ధి చెందడానికి అవకాశం ఉంటుంది. అందుకే మానవ వనరుల నిర్వహణ, హ్యూమన్ రిసోర్స్ డెవలప్మెంట్. We have much human resources, but how to utilize, how to make it utilize, it is very, very important. Human resource management, human resource development. Then modern economists in recent years have pointed out developing countries have remained underdeveloped. Developing countries have remained underdeveloped because of underutilization of human resources. Because of underutilization of human resources. Underutilization. Underutilization of human resources. అభివృద్ధి చెందుతున్న దేశాలు వెనుకబడి ఉండడానికి గల కారణం తక్కువగా మానవ వనరులను వినియోగించుకోవడం. అండర్ యూటిలైజేషన్ ఆఫ్ హ్యూమన్ రిసోర్సెస్. సో therefore large scale of human resources, therefore the large scale investment in human resources are needed. The large scale investment on human resources are needed. If physical capital available in their countries is to be exploited more fully and in a more efficient way. So this is all about the meaning and importance of human resource development. Question, they may ask you, what do you mean by human resource development and how do you improve it? What is the meaning of human resource development? How do you improve it? How do we improve more and more investment on human resources? Okay, capital investment, human resource, human capital. Human capital means expenditure on education, health, trainings and other important activities. That is human capital. In the last previous questions papers, what is the meaning of human capital? They asked as a 2 marks. Human capital. Human capital means expenditure on health, education, trainings and experiences. So this question also very important for 5 marks. And even what is the meaning of HR, human resource development? They may ask you 2 marks. And also what is human capital? Human capital also. So then coming to role of education in economic development. Role of education and economic development. Role of education and economic development. How education can contribute to economic development of any country. So as we know that education is every sense is one of the fundamental factor of development. Education is every sense is one of the fundamental factor of development. No country can achieve sustainable economic development without sustainable investment on human resources. No country can achieve sustainable economic development without investing on human resources. మానవ వనరుల మీద తగినంతగా పెట్టుబడి పెట్టకపోయినట్లయితే ఏ దేశం కూడా అభివృద్ధి చెందడానికి అవకాశం లేదు. సో therefore education is an important tool. It is a weapon to change a country. According to Michael P. Todaro, MP Todaro and Adam Smith. According to MP Todaro and Adam Smith, these two people, they explained that education contributes to economic growth. Education contributes to economic growth in the developing and developing countries. It helps in creating a more productive labor force and with increasing knowledge and skills. So according to these two people, education contributes to economic growth in the developed and developing countries. It helps in creating a more productive labor force and with increased knowledge of skills. It helps in providing widespread of employment. Education can providing widespread of employment and income earning opportunities when more schools, colleges and universities come into existence. When education, as long as it expand, more schools, more colleges, more universities can provide education and also can provide employment for the professional workers. It helps in creating a class of educated leaders. Education also helps in creating a class of educated leaders to fill vacant positions in government services, public corporations and public business, private business and professions. Education also helps in providing basic skills and encourage modern attitude. Education also provides basic skills and modern attitude in the diverse segment of population. Then coming to role of education in economic development. First one is there are few important sub-concepts are there. Education and economic development. Education and economic development. First one is education and economic development. Education and economic development. Or education, economic growth. Education and economic growth. Just we have seen according to MP Todaro and Adam Smith, education contributes for economic growth. Without proper education, no country can develop. Education, it has a lot of changes can bring into an individual in a family life, especially in rural women attitudes. Then coming to second one is education and reduction in income inequalities. Education is seen as a great egalitarian measure. Egalitarian means advocating equal rights to all. Andariki samana avakasam. Education, it is a level playing factor. Education provides equally to all. Everybody can get equal opportunities. So therefore, education is seen as a great egalitarian measure which would help in improving the human resources in general. Then coming to education and rural development. First one is education and rural development. Education and rural development. How education can contribute for the development of a rural economy? Education can contribute significantly to rural development in a variety of ways by widening the horizon of the knowledge of the rural people. It can enable them to overcome ignorance and superstitions. It can enable them to overcome their ignorance and superstitions. Adopt a new agricultural techniques and new methods of production is rendered earlier. If the farmers are educated, they can implement better inputs to get more output from the agricultural field. Education can be oriented as to improve skills and attitude, usefully improving the quality of family's life. Then education and family planning. Both one is education and family planning. Education and family planning. Education helps in modernizing and making the way of thinking of the people. It enlightens them of the need of improve their standard of living. Education, modernizing and making the way of thinking of the people. It enlightens the need of improve their standard of living and restrict the size of family. As long as more and more women become educated, as long as more and more women are educated, they can give less importance to fertility. They can give less importance for maternity. They can go for, they seek job and the fertility rate shown to tendency to be decline. Fertility rate అనేది తగ్గుతుంది. ఎందుకు? మహిళలు వాళ్ళు లేటుగా మ్యారేజ్ చేసుకున్నట్లయితే పిల్లలు లేటుగా పుట్టడం జరుగుతుంది. ఎర్లీ మ్యారేజ్ లీడ్స్ టు more children. If women become educated, they can go marriage for a late age. In that way, population can be reduced. So, education can bring more changes in the attitude of a women. So, therefore, more and more women should educate. Then other benefits of education. Other benefits of education. In addition to benefits above discussed, and there are other benefits also. Under that, meeting of the skilled manpower requiring a growing population. Meeting of the skilled manpower required for growing population. పెరుగుతున్న జనాభాకి skilled manpower అందించడంలో education contributes a lot. Then the provision of environment that stimulates research in science and technology. The provision of environment can stimulate the science and technology. Then education enhancement of the enjoyment of leisure by widening of the intellectual horizon of both educated and uneducated. Finally, education enrich people understanding to themselves and the world. Education enrich people to understand themselves and the world. So there are a lot of merits if a person is become educated. So therefore, education immensely it helps the individual, society, and a country development. So far, we have seen that what is the role of education? And education and economic development. Education, its reduction in income inequalities. Education and rural development. education and family planning, and other benefits of education. This question also very often they are asking for IPP, but 5 marks. Sometimes they ask a 10 marks question also. So very, very important. Then coming to education in India. Education in India. Education in India. Education in India. So, education is a very important factor in the economic development of any country. Education is an important factor in the economic development of any country. India, since the early days of independence, India, since the early days of independence, has focused on improving the literacy rate in our country. Even today, the government runs many programs to promote primary and higher education in India. But the public expenditure on education sector, it is inadequate. The public expenditure on education sector, it is insufficient or inadequate. So therefore, recognizing the importance of education, public expenditure on education was increased considerably. Public expenditure has increased on education considerably during 11th Five-Years Plan. During 11th Five-Years Plan. 11th Five-Years Plan. What is the period of 11th Five-Years Plan? 11th Five-Years Plan period is 2007 and 2007 and 2012. 11th Five-Years Plan, there is a lot of importance has been given to agriculture sector. Education sector. So here it is nearly 4%. 4% allocations allotted for education sector in GDP. 2011 and 2012, nearly 43% public expenditure incurred for elementary education. Primary education. Nearly 25% of public expenditure on secondary education. Secondary education. Whereas 32% expenditure for higher education. Higher education. That is university education and research and development. So in the 12th Five-Years Plan, 12th Five-Years Plan period is 2012 Five-Years Plan. 12th Five-Years Plan period is 2012 to 2017. 12th Five-Years Plan. Even 12th Five-Years Plan, gross budgetary support for Ministry of Human Resource Development is rupees 4,53,728 crores. 4,53,728 crore, for which rupees 3,43,028 crore is for development of school and secondary education. And the remaining 1,10,700 crore for Department of Higher Education. Department of Higher Education has been allocated. So during 11th Five-Years Plan and 12th Five-Years Plan, lot of allocations, expenditure on education is very enormously high. So therefore, 11th Five-Years Plan, we can say that it is a education plan. 11th Five-Years Plan, it is an education plan during Manmohan Singh. Then coming to Sarva Shiksha Abhiyan. Sarva Shiksha Abhiyan. It is very small question for 2 marks. Sarva Shiksha Abhiyan. Sarva Shiksha. Sarva Shiksha. Sarva Shiksha Abhiyan. SSA. Sarva Shiksha Abhiyan is very important for 2 marks. This program has been introduced in the year 2001 and 2002. 2001 and 2002. With the aim of providing universal elementary education. With the aim of providing universalization of elementary education for the age group of 6 to 14. 6 to 14. 6 to 14. For all children, 6 to 14 age groups. Besides, the Sarva Shiksha Abhiyan intend to bridge social, regional and gender gap. Besides, the Sarva Shiksha Abhiyan basically intend to bridge social, regional and gender gap with the achieved participation of the community in the management of school. Under this National Program for Education Girls at elementary level, National Education for Girls at an elementary level is an important component of Sarva Shiksha Abhiyan. If 2 marks question ki Sarva Shiksha Abhiyan వచ్చినట్లయితే, the main aim is universalization of elementary education. It is meant for the years 6 to 14 years. 6 to 14 years. This program has been introduced in the year 2001 and 2011. If you write like that, you will get 2 marks. 2 marks. Then coming to role of health in economic development. Role of health in economic development. Role of health in economic development. Role of health and economic development. Role of health and economic development. This is also very important question for 5 marks. Role of health in economic development. As we know, the efficiency of workers. The efficiency of the workers depends on their health. Efficiency of the workers depends upon their health. Healthy people are more vibrant and energetic. Healthy people are always, they are more vibrant and energetic and have more positive outlook on life. Workers whose health is not good, if they fall sick, they cannot contribute more for the national output. They cannot participate more in their works. They cannot participate in any job effectively. Then improvement in the health of the workers automatically raises the national output. If we improve the health conditions of workers, automatically the national income can achieve. The national income can achieve. And improved health contributes economic growth. Improved health contributes. Improved health contributes economic growth. Improved health contributes economic growth. Economic growth. It reduces the production losses. If a person is become healthy, it reduces the production losses. Reduces the production losses. Production losses. Then second one is it permits the use of natural resources fully. It permits the use of natural resources fully. ఉన్నటువంటి లేదా అందుబాటులో ఉన్నటువంటి సహజ వనరుల్ని కంప్లీట్గా వినియోగించుకోవడానికి అవకాశం ఉంటుంది. ఇట్ పర్మిట్స్ ద యూజ్ ఆఫ్ నేచురల్ రిసోర్సెస్ ఫుల్లీ. Then coming to the economic gains are relatively greater for poor people. The economic gains are relatively greater for poor people if they become healthy. If they become healthy. So therefore, World Health Organization, what they explain? Health is wealth. Health is wealth. They could not say that wealth is health. వాళ్ళు ఏం చెప్పారు? హెల్త్ ఈజ్ వెల్త్. ఆరోగ్యమే మహాభాగ్యం. కనుక ఎవ్రీబడి దే షుడ్ టేక్ కేర్ ఆఫ్ దేర్ హెల్త్. They should take care of their health. And during this corona disease, we should be very careful about our health. So here, the economic gains are relatively greater for poor people if they become healthy. But two things are essential. Two things are very essential here. First one is, if a person become healthy, first one is balanced and nutritional food. Balanced and nutritional food. Balanced and nutritional food. Balanced and nutritional food. Second one is health care. Second one is medical care. Medical care. Balanced and nutritional food. Balanced and nutritional food, who can take? Only rich people can take. Rich people can take. Whereas poor people, they cannot afford to purchase more balanced and nutritional diet. Dry fruits, they cannot purchase. Meat and fish, they cannot purchase regularly. Very, very rare. Whereas rich people always, they are very particular about balanced and nutritional food. And everybody should take medical care. These two things are very, very important for all the people. In India, if we see during last 6 decades, there has been considerable achievement in improving health standards. The last 6 decades in India, there is a lot of considerable achievements in health sector in terms of reducing life expectancy and increasing the life expectancy, reducing infant mortality and reducing maternal mortality, and smallpox, plague have been eliminated. Smallpox and plague also we have eliminated from India during 1960s and 70s. And there are several other diseases also like malaria, tuberculosis, TB, diarrhea have been controlled in a large extent. But a rise in the incidence of certain diseases. ఇప్పటికీ కొన్ని వ్యాధులు అనేవి ఇండియాలో ఉన్నాయి. Say for example, AIDS, blindness, cancer. These requires immediate attention to and care and actions. ఇవి పోవడానికి గవర్నమెంట్ they have to focus on health sector. So there are certain weaknesses are there in Indian health sector. Weaknesses. What are the weaknesses in Indian health sector? Certain weaknesses in Indian health sector. One is unequal distribution of existing health infrastructure and manpower. Unequal distribution of existing health institutions and manpower. It means more manpower is there, but less institutions are there. There are few hospitals are there. Hospitals are very few. In some states, institutions are more, but manpower is less. And second one is mismatch between personal and infrastructure. Mismatch between personal and manpower. Infrastructure. Staff ఎక్కువగా ఉంటే ఇన్ఫ్రాస్ట్రక్చర్ తక్కువగా ఉంటుంది. హాస్పిటల్ థియేటర్ ఉండదు, గదులు ఉండవు. గదులు ఉన్న దగ్గర మ్యాన్ పవర్ తక్కువ ఉండే పరిస్థితి. అండ్ అగైన్ ద ల్యాక్ ఆఫ్ అప్రోప్రియేట్ రిఫరల్ సిస్టమ్ అంటే చిన్న హాస్పిటల్లో అపోలో హాస్పిటల్ రిఫర్ చేసే సిచ్యుయేషన్ అనేది లేదు. అట్లానే ఇంటర్నేషనల్ హాస్పిటల్కి లేదా అదర్ స్టేట్స్లో తమిళనాడు, బెంగళూరు అటు పైకి రిఫర్ చేయడానికి డాక్టర్స్ అంత కమ్యూనికేషన్ నెట్వర్క్ అనేది లేకపోవడం, రిఫరల్ సిస్టమ్ కూడా ఇండియాలో చాలా వీక్గా ఉందని మనం చెప్పవచ్చు. సో దిస్ ఈజ్ ఆల్ అబౌట్ రోల్ ఆఫ్ హెల్త్ అండ్ ఎకనామిక్ డెవలప్మెంట్. This is also when I ask you for 5 marks. And coming to health schemes in India. Health schemes in India. So, health is a fundamental human rights. As we know, health is a fundamental human rights, and globally it is a social goal. National Rural Health Mission, NRH, National Rural Health Mission, which is introduced in India during 2005. So under this, to provide accessible, affordable and quality of health services to rural India. To provide accessible, affordable and quality of health services to rural India. In rural areas, the government extended NRHM. Rural area NRHM, National Rural Health Mission, is introduced in 2005. Whereas NUHM, it is in urban areas. Rural areas like the National Rural Health Mission. So, if we see the different schemes, first one is accelerated social health activists. ASHA workers are there nowadays in every village. And Janani Suraksha Yojana in year 2005. Janani Suraksha Yojana. ASHA workers and Janani Suraksha Yojana, JSY, Janani Suraksha Yojana 2005 to bring down MMR, maternary mortality rate. Pradhan Mantri Swasthya Yojana, Rogi Kalyan Samiti, Aam Aadmi Bima Yojana. Then again, Janasri Bima Yojana, Universal Health Insurance Scheme. Then Ayush, Ayurveda, Unani, Siddha, Homeo. Ayush also there. Then again, Janani Sishu Suraksha Karyakrama, JSSK, was also, it is launched for mother and child care. These are all health schemes in India. To provide accessible, affordable and quality of health services in rural as well as in urban areas. Then coming to Human Development Index. Last class we have read this small questions, that is HDA. Human Development Index, HDA. It is also, they may ask you for 2 marks. The United National Development Program, UNDP. United National Development Program. They have introduced HDA, Human Development Index first. HDA report prepared under the stewardship of Mahabub Ulhuk. During 1990s. During 1990s. HDA broadly classified 3 see, according to recent years, it is nearly 69 for male, it is 70 or 74 for women. For female, life expectancy at birth rates. And second one is knowledge is measured in terms of education. Knowledge or education. Third one is the standard of living. It is measured in terms of PPP, purchasing power, and standard of living. Standard of living. So HDA always is calculated. HDA Human Development Index అనేది మనం క్యాలిక్యులేట్ చేయడానికి జనరల్గా యాక్చువల్ వాల్యూ మైనస్ మినిమం వాల్యూ by minimum value, maximum value minus minimum value. So far we have been discussed important concepts in the second chapter, that is population and human resource development. What are those? First one is what is the occupational distribution of population? Under that, what is the dependence on agriculture sector, dependence on industrial sector, dependency on service sector. So there is always close relationship between economic development and people changes in occupations. Then coming to, we have seen what is the meaning of human resource development. What is the importance of human resource development? Then we see that what is the role of education in economic development. Under this, education and economic growth. Education and reduction in income inequalities. Education, rural development. Education, family planning. Other important factors for education. Then education in India. During 11th 5-year plan, during 12th 5-year plan, what is the expenditure on education? That also we have discussed. Then Sarva Shiksha Abhiyan. When this program has been launched or introduced. What is the main aim of Sarva Shiksha Abhiyan? And what is the role of health? Health and economic development. And what are the different schemes with the health schemes in India. So far just we have seen the list. Then finally we see the Human Development Index. Earlier there are indexes. National income is the better indicator. Then Human Development Index is a very important thing. UNDP, they have prepared this HDA according to during 1990s. ఇందులో మనం 3 important things, life expectancy at birth rates, knowledge in terms of measure of education, and standard of living in terms of measure per capita income. So if we calculate the formula is actual value, minimum value, and the maximum value minus minimum value. So this is all about this chapters, population and human resource development. Thank you, one and all. We see in another video. Until then, bye.